Hi friends, in previous video we have covered second question, right? So today we are going to discuss third one. Okay, in this question what they given, use division algorithm to show that square of any positive integer is of the form 3p or 3p plus 1. Okay, so we need to show whether square of any positive integer is of the form 3p or 3p plus 1. So first they are asking positive integer, so I will consider let a be any positive integer. Okay, let a be any positive integer. I am assuming that a is one positive integer. Okay, so if a is a positive integer, same just like a previous problem, by division method. Okay, we already know by division method what we have, a is equals to bq plus r. This is our condition, right? A equal to bq plus r, and similarly 0 less than or equal to r less than b, right? So here let us assume b value equal to 3 here. Why? Because we need to prove 3p or 3p plus 1, so it is in the form of bq plus r, right? So I am assuming b equal to 3. If I am assuming b equal to 3, what will be the reminders? R less than 3. That means we are able to get 0, 1 or 2, right? So 3 reminders we are able to get. So first try to put r equal to 0 in this equation, b equal to 3, r equal to 0. What happens? A is equals to 3q plus 0. That is the first equation. Second equation, you put b equal to 3, r equal to 1. So a is equals to 3q plus 1, right? Again similarly third equation, a is equals to 3q plus 2, right? Instead of r I am taking 0 one time, 1 one time, 2 one time. So we are getting 3 different equations. But this is not the final conclusion what they are asking. They are asking us to do what? Square of any positive integer. So we assumed a, right? For a we got 3 values. They are asking us to do square. Okay, square of positive integers. So that's why I will do squaring on both sides for this. Okay, so you do squaring on both sides. What you will get here? A square is equals to 3q whole square, right? So a square is equals to 3 square means 9. This one is q square, right? A square is equals to, can we write like this, 3 into 3q square, because 3 3 is 9. Again you are getting the same answer, right? So a square is equals to 3 into, I will assume this total term as 1p constant. Okay, we are getting a square equal to 3p. Is it the same what they are asking us to prove? 3p. Okay, so here q means what? Any positive odd integer, any positive integer you can take here. So you will get some value. That value I am assuming it here as p. So we are able to get the first conclusion. Square of any positive odd number should be equal to 3p. It is in the form of 3p. Okay, that is fine. That is completed. Next, you do for this squaring on both sides. Okay, if you do squaring on both sides here, what you are going to get? A square. This is what? 3 plus 1 whole square, right? So a square is equals to a plus b whole square, right? You do a plus b whole square, apply a plus b whole square formula. A square, that is 3q whole square plus b square plus 2ab, 2 into 3q into 1, right? 2ab. So here a square is equals to, what you are going to get? 3 square means 9, q square plus 1 plus 2 3 is 6 q, right? So here a square is equals to, what you are going to get? 9q square plus 6q plus 1, right? From here can I take 3q common? If I take 3q common from these two, what you are going to get? 3q here, okay, plus 2 here, right? Again you have plus 1 here. I am writing as it is, plus 1. Okay, now you see 3 into 3 9, q into q square, 3 2s are 6 q. Okay, we are getting above result or not? So you just take 3q common from these both terms. Plus 1 I am writing as it is. Just you only take 3q common from these both terms. 3q common, so automatically what will be left here? 3q. Here what will be left? Only 2, right? If you take 3q common, so now again same thing. So 3q, this is any one term, right? This is any one term. Let us assume k plus 1. Okay, a square into q into k is also any one term. Let us assume p plus 1. Now you can see again we got one answer or not. A square is in the form of 3p plus 1 or not. They are asking us to prove the same thing or not. Okay, so this is how you have to prove. They are asking us to do square, so that's why we did square in this problem. In previous problem we have not done square because in question they have not asked. Clear? This is how you have to get the answers. Okay, thank you.